I am going to be canceling office hours today, both because of the snowstorm and because I have a cold. So, not the flu, not contagious that way, but I wouldn't suggest you come up and see me after class either for that reason. So, no office hours today, but I will be answering queries by Piazza, so feel free to, if you have questions, to post them via Piazza. Reminder, the TA office hours are in MinCal 217, not the programming clinic. So make sure you go to MinCal 217. Also, a reminder that the Jan16 exercises are due at 11 a.m. So they're due 10 minutes before class, and that's because it gives me the option of 11 a.m. or 11:30. If I say 11:30, then some of you will work on them during class, which is not what I want. So I want you doing them before class. Also, I just want to reiterate that making you do it before class is a good study habit. I know it's hard to make yourself read a book before coming to class, but it actually means you're much better prepared for class. It's a good study habit that would be beneficial for you to carry over to your other classes, but I know it's difficult. Sometimes also, there may seem like there's a lot of participatory activities that I've assigned. They generally are very quick. Some of those participatory activities are animations. They're just animated figures. They're not even asking you to do any kind of response. Also, most of the participatory activities are just things like true, false, or fill in the blank. I'm not making you do programming in general. Sometimes there's one programming one, but in general, it's just exercising your muscles so that you're not doing passive learning. Okay, again, the research shows that when you're forced to do these kind of interactive exercises while you read material, you understand it better and you do better on exams. Like I said last time, when I apply the format that I am applying in this class to the CS 102 class, my grades go up by about half a letter grade to 2/3 of a letter grade. So this is the first time I will be trying this approach in this class, but I've had success with it in other classes. So just stick with it. I don't, especially early, there may seem like there's more participation activities, but they go quite quickly. You can also immediately see the answer. So basically just doing them gives you 100%. Okay? So for all those reasons, I find them very helpful. Okay, so today, as I said at the first class, yes?
Sorry, is the textbook material going to be like a big part of the exams coming out?
Big part of the exams?
Like, I'm wondering, like, for example, are the questions from like the study from last night, is that a big part of the exams?
So, must say that sometimes, not really. I guess I don't. If this was another class where I gave more multiple choice type questions, the answer would be yes. Here, I tend to give more yes. Some of the questions there that aren't true false, that are asking you to do things like look at code or say fill in what parameters, how you declare the parameters, those would end up on exams potentially, yes. But and then when you get more later toward things like hashing, then the participation activities really start to look even more so like what you'll see on exams. Because then it'll be like, here's a set of values, put them into a hash table. Well, that's exactly what I'll do to you on an exam. So the answer is yes. The true false, multiple choice, probably not so much. But some of the, where you're completing stuff, yes. They could look very much like what you see on exams. Other questions? Okay, so like I said, first class period, first month, we're really going over review, but deepening your knowledge of things. So today, we're going over input and output, specifically from standard in and standard out. So standard in, if you remember, is what we often call the console. Standard out is your screen. as opposed to files, which we'll get to in a couple more days. And the two tools that you were taught in CS 102 were CN for input and Cout for output. Okay? Today we're introducing another one for output called Printf. And we're going to make you use Printf for a couple labs before we then let you use either Cout or Printf, whichever you're more comfortable with. But you need to get familiar with Printf. It stands for Print Formatted Output. And it is a command that is a holdover from C, but it's less verbose than Cout, and so people often use Printf rather than Cout. So actually going to start today by talking about Printf, then going to have you do a short programming exercise with CN and Printf, and then we're going to go over some of the bugaboos that frequently afflict you with CN, and that also you will need for your next couple labs. So Printf, let's take a look at Printf. I'm going to assume you pretty much know how to deal with Cout and that the Jan16 text has also given you that good review for Cout. But the Jan16 text does not talk about Printf. So the simplest form of Printf, here it is. So Printf looks like a function, and in fact is a function, where the first argument is what is called a formatting string, and then any other arguments are the variables you want printed. Here, you're not printing any variables. You're just printing the string hello world. And unlike Cout, where you got to use endl, you only get to use \n if you want a new line. So at the end of that string, you see \n. So it's saying print hello world and then a new line character. So that's all well and good, but we typically want to print variables. Okay? So let's say that instead we have this little program that's calculating squares. Okay, I squared from 0 to 10. Now you'll see that we have I is %d, I squared is %d. So these %ds are what we call formatting directives. Okay? They are telling Printf that right here, this %d is going to be replaced with an integer variable. And it is going to be matched, in this case, this is the first %d, this is the second one, and this is the third one. So they're going to be matched, this will be matched with the first one, this j will be matched with the second one, this I times 2 will be matched with the third one. So the first %d will be replaced by the value of I, the second %d will be replaced with the value of j, and the third %d will be replaced with the value of I times 2. So you can provide these formatting directives to the formatting string. So everything that's not a formatting directive is simply printed directly to the screen. So if you look down below, you can see that I is copied directly to the output. And then the value of I is the next value printed. Then minus is not a minus I times I is, none of that is a formatting directive, so it is copied directly to the output. Then %d, it prints out j, which has the value 0, so on and so forth. Okay? So there are some other formatting ones. If you want to print a string, %s says that the variable you're printing out is a string variable. %F says that what you are printing out is a float or a double. %C says that what you're printing out is a char. And either %D or %I, you can use either one, says that you're printing an integer. So those are the 4 basic ones that you print. And unfortunately, there is no way to say we're printing a Boolean. If you try to print a Boolean, it's printed as an integer, 0 or 1. So no way you can print a Boolean, but if you're printing a Boolean variable, you have to say that it is an integer. So in fact, I will say here, integer or bool, because that's how you print a bool. Yes?
Just clarification, %D, that's not double, that's...
That's not double, right. That's unfortunate. Exactly. %D stands for digit. I agree. So weird, so unfortunate. So you may want to consider using %I, just so you don't run into that problem. But yeah, I agree. %F and %D would be better for float and double. I am not giving you misinformation. %D is an integer. Okay. Now, that's all well and good, but you may remember that there were some things that you like to do with cout. So what are some of the things you remember wanting to do with formatting with cout other than just dumping, say, a number to the screen? Alignment. So you're right, I omnip, but there's certain things that I want. So alignment, it could be left justified or right justified. Does anyone remember by default how variables are justified? They're right justified. Even strings by default are right justified. So you might want something to be left justified. Now, that only makes a difference if you provide a width for the field. So that was something else you could provide. So some of the formatting directives you could provide were width of a field. So field width. Alignment, which is also justification. Okay, so to say the width of a field, between the % and the type of the variable, you put the width. So if you want a 20 character wide field, you say %20s, and now it prints it in a field that's 20 characters wide. Okay, and does anyone remember what happens if the string is longer than 20 characters? What if it's 30 characters? What happens? Does it cut it off? It does not. Okay? If this is minimum width, if the string is larger than the width that you provide, then the entire string is printed out. Okay? I'll show you. If you don't believe me, don't expect you to necessarily. Let's do print.cpp. And let's do a string. Let's not even bother with that. So print %5 string, and we'll start with Brad. Let's make it 10 wide. Okay, so it's saying I want a field that is 10 characters wide. So if we execute, you see Brad is printed in a field 10 characters wide, and it's right justified. Now let's make it bigger than 10. Okay? It didn't truncate it. It printed the whole thing. So that's just the minimum width. If the field is bigger than, or if the value is bigger than the field, it prints the whole thing. Okay, now let's say we want it left justified. The way we get left justification is with the minus sign. So minus says left justify. So I put a minus right there before the 10. And if I compile it, it's now left justified. So a minus sign, so alignment, default is right, justified. Put a minus sign, it will left justify it. That's true of any of the things. If you put a minus before the field width, it will left justify it. But only for that one thing. It will go back to being right justified for subsequent ones. So you have to specify this for every variable you're printing out that you want left justified. Hey, and the field width is a minimum width, but it doesn't truncate. Okay, won't truncate. What's another thing? So field width and alignment were two things. What was another thing? Pardon? Set fill. So you sometimes want a fill character. So here, when we print it out right justified, so I'm going to get rid of the minus sign. In fact, let's do something here. Let's make this a little smaller and create a second window so that I don't have to get rid of So coming over here, if I want a fill character, then I can put a fill character in front of it. So let's say I want an asterisk in front of it. Then in front of, not in front of, whoops, yes. I want an asterisk to fill out the extra spaces rather than a blank space. So I will compile it again. And it didn't like that. One warning, format invalid. Why? Let me check something. Whoops, don't want Safari. Fill. No, what are you doing to me? Let's get rid of this for a moment. I'm not doing it there. Okay, let's do this. Whenever you're in question mark, printf with fill, what am I doing wrong? Wonder if it's only going to work with a number. Let's just change something for a second. Okay, let's put a 05 here. You're still not liking that. What are you not liking here? Percent. Someone should kill their cell phone. Printf percent 0, 9.3. It sure looks like that should be working. So it's working with a number. Why don't you like my asterisks, which are also supposed to work? Okay, I will get back to you on why my fill characters aren't working with asterisks. That seems odd. So certainly putting something like a 0 there in front of it is going to cause it to be filled with zeros instead of with blank spaces. What I'm not understanding is why my asterisk isn't being taken. That seems odd. So let's try this now with strings. It may not even work. So we'll do it again, Brad. And it looks like with S's, you can only get your fill characters with integers and numbers. It looks like it's not going to work with strings. So I will look at fill characters again because I thought that should work with both asterisks and with numbers. So we'll put fill characters off for a moment. So fill characters was a third thing. What is a fourth thing that we typically want to do with printf or with outputting? Set precision. So we want to control the number of decimal digits. Okay? So the way we do that, that's only with floating point numbers that we're trying to control the number of decimal digits. So here we have outside temperature, 103.45. And if we just say print %f outside temperature, then it's going to print the whole thing. In fact, it might print, there you go, it prints the whole thing. In fact, there's an extra 0 right here. Right? So if we want to control the number of percentage points, the number of decimal digits, we put a dot and then the number of digits we want. So in this case, let's say we want 2, we say %.2f. And now it will be limited to 2 decimal points. When I print it out, do you think it's going to print out 103.45 or do you think it's going to print out 103.46? Let's take a vote. How many of you think it's going to print out 103.45? And how many think it's going to print out 103.46? You would be right, it does rounding. So it will round to the nearest number. In this case, it rounded up because the extra values to the right here were greater than 5. Yes?
Is it modes here or apply?
Pardon?
Are there like modes like scientific and fixed?
Yes, there are modes like scientific and fixed, but since I never actually use scientific, I forget what it is. So I will not try to tell you what the scientific one is. Okay, by default, you actually get scientific mode. And it's only when you give it these directives like 0.2f that you get the fixed point mode, what we call fixed point. In 102 with cout, you actually had to explicitly say fixed. Remember, and if you didn't, then the precision would actually control the total number of digits, not the number of digits after the decimal point. But here, when you say 0.2, it automatically assumes you want fixed point now, rather than scientific notation. Okay. Now, if you want it also to control the number of characters in the field, so let's say I said 10, now it says the total field width is 10. That includes the digits in front of the decimal point itself, and the digits after. So in this case, there's 10 digits. How many can be before the decimal point? Nope. Try 7. Because it's 10 wide, the dot is 1, and then 2 after it. Except, again, it won't truncate. So we're saying we expect the number to be no bigger than 7 digits before the decimal point, then the decimal point and 2 after it. But if it so happens that the number is bigger, then it will use up as much space as it needs. So let's just try this one right here, and you'll see it comes up with 103.46, but it will be right justified. Now, let's make it smaller than 10. Let's make it be only 3 digits wide. Okay, and redo it. Now it took up how many digits? How many spaces? 6. Even though over here, whoops, it said there should be only 3. So again, no truncation. Okay, so those are your big format specifiers. Is the field width, the alignment, which is a minus if you want left justified, the number of decimal digits, which is point, and then you say point and then the number of digits you want, and I will get back to you on the fill character. So at the bottom of these notes, there is a summary for you. So every semester I get people going online saying I can't figure out how to use Printf, and it's like, well, it's in the notes. Okay, and especially at the end of the notes is this recapping the formatting directives for Printf. So it's all there for you. The alignment operator first, then if there's going to be any leading spaces, the asterisk. I'll try this again to see because I know it worked when I tried it this way. Then the field width, so the alignment operator first, the fill character second. These are optional. So is this optional? And then the number of digits after the decimal point. It should only be used, in this case, number of digits after the decimal point if you're printing out a floating point number. Because it doesn't make sense with any other thing. Okay? And the percent sign is critical because that tells the printf that that's the start of a formatting directive for a variable, to say I want to print out a variable. And again, these formatting directives are associated with variables after the formatting string. So there's a formatting string. So printf is a formatting string, which is in double quotes, and then your variables. And the formatting directives are directly lined up with each of the variables. So the first formatting directive prints out variable 0, the second one prints out variable 1, and so on. How do you think you get a percent sign into your string? Because sometimes you'd like a percent sign to be output. Doesn't work with double quotes. Good try. Backslash, I heard it. If you want a backslash, if you want a percent sign, so if you want to say 36%, you have to say something like %d backslash %, and that the backslash escapes, we call it escaping the percent sign, and it says I literally want a percent sign in the output. So if you want a percent sign in the output, you need to put a backslash in front of it. Okay? Questions about that? Okay. So it's time for you to give this a whirl and to get some practice with Cin and Printf. What I want you to do is very simple. I want you to write a short program. If you don't have your laptop, write it on a piece of paper. If you do have your laptop, try to do it in the terminal window. If you don't have, you can always secure shell into our Hydra machines. So you can do that. If you're not quite sure how to do it, but you have C++ loaded on your local machine, do it on your local machine. If you can't yet use the console window, use Code Light if that's still on your computer. But all I want you to do right now is read one floating point number and print it using Printf in a field 10 characters wide with 1 decimal point of precision. Okay, and you're free to work with a neighbor on this. I'm going to give you 5 minutes to 11:48. In fact, I will give you, if you forget the initial form of how to do this, include IO stream using namespace std, put a return 0, so that's the shell that you should use. By the way, the notes say, for safety, you should say C standard IO for printf, but it turns out most of the time IOStream gets you printf. But if for some reason IOStream doesn't get you printf, then C standard IO will, because printf was a C command. Okay, so here again, here's that. Here's your shell on the right. Here's your thing to do. If you get it done, then try reading repeatedly floating point numbers and printing them. So use a loop if you get done with this first part. Okay, I know you may not have finished, but I am going to do it, show you the correct answer. In general, it is better to use doubles rather than floats. Does anyone remember why? Higher precision. So a double theoretically gets twice or double the number of bytes that a float gets. So supposedly a double should get 64 bytes and a float should get 32 bytes. So a double is supposed to be able to store bigger numbers. Whether your machine actually implements it that way or not is kind of platform dependent. But in general, it's safer to use doubles because they can represent bigger numbers. So we will say double number. Cin will read the number from standard in. Printf, and all I want to do is print it. I will just say number equal, even though I didn't tell you to say that. But just to show you, I can also print out some explanatory stuff. Percent is my formatting directive. I said the field should be 10 characters wide with 1 decimal point of precision. F is the directive for a floating point number. I would like it to print a new line character, so I put the new line character and then number. Okay? Let's see if that works. So I compile it. It didn't like. I can't spell. It's not CSDTIO. It is STD, standard STDIO. Okay, and now it's waiting. The reason it's just sitting there is it wants some input from me. So I enter 6, it prints 6.0, and it's right justified. That's why there's so many spaces. I enter 6.38, and it prints out. If I enter 6.38, what do you expect it to print? 6.4, because it's going to round up. Okay, you might think, okay, what happens with 6.35? It rounds down. Okay, you may wonder, does anyone know why sometimes it may round down and sometimes it may round up? Pardon? No, it's not because it's even. It's a good guess. Because you can't always represent 0.35 precisely. Okay, remember from 130, you have to use fractions, right? So 0.3 is really 0 1/2 plus a quarter, 1 1/4 plus 0 1/8 plus 1 1/6, right? 1/16. So it's having to approximate 0.35. So sometimes, actually always, it's either going to be exact or it's going to be what? Greater than or less than? Less than. So it may really be internally 6.344449. So it's generally going to look like it gets rounded down. Okay, let's try 2.5 because 2.5 can be exactly represented. Whoops. But nothing else can be. Actually, 2.5 is 2.5. I can't get anyone. 6.25? 2.25 can be precisely represented. And it's still rounded down. So in fact, you're always going to round down. Okay. How would I have left justified this? Put a minus. So if I put a minus in here, and it's left justified. Okay? Now, just for grins, let's put in some bigger stuff. Still works. Now let's put in a huge number. Okay, it worked. Actually, wow, I didn't realize I could get that big of a number. Well, that didn't work. 3056, what happened? No, this isn't rounding down. 5868, this has nothing to do with this. The numbers are different. They're accurate for a while, but it lost it right here. Yeah, right there I think is where it lost it, somewhere in there. At any rate, somewhere it loses the precision. What happened? The number was too large. It couldn't fit this entire number in a double. So it did the best it could. It approximated it. First of all, it lost the fraction because the fraction is insignificant if it can't even represent the whole thing. Then it represented it as best it could. Okay? But that's the closest, this is the closest approximation right here that it can get to this number. It's the closest approximation it can get using the number of digits or bits it has for a double. Okay? Questions about that? We won't really worry a whole lot about overflow right now, but this is called an overflow situation. Okay, it was too big, and it approximated the number as best it could. Okay, so moving on, let's say we want to, let's try something else. Let's enter a string, foo. It's expecting a number, but users don't always enter the right input. It returned 0.0. So it was unable to convert it. We still may not know what happened, but I do. It was unable to convert foo to a number, so whatever was already in number remained there. It didn't change it. So it became, it stayed at 0. Now you can't assume that things will always be 0. This was a mistake many of you made in 102, is assuming that uninitialized variables will always be set to 0. That's not always the case. They will be whatever was left there. The computer doesn't go through and zero stuff out. Whatever garbage was there before number is what you will get here with a bad input. Okay? So, let's though go to, we're going to show you that we can fix this problem. We can check to see whether the number was bad or not. But I did say, let's try reading a whole bunch of things. So if you remember, the way that you read a whole bunch of numbers is using this idiom. So in this case, I want to read a whole bunch of numbers. So I'm saying while cin into number, print it out. Okay, so now I have something where I can keep entering numbers and it will keep printing them. Now let's enter a bad number. And it stopped. Okay? It didn't even print out the number. It just stopped. Okay? So what happened? Well, what happened is that this expression, cin into number, right here, it returns a Boolean value, true or false. It returns true if the read succeeded and false if the read failed. In this case, the read failed, so it returns false. and therefore the loop exited, and we terminated the program. That's why nothing even printed out, because as soon as I tried to read in foo, the expression over here, it failed, and it dropped out of the loop. Okay? Does that make sense? Now, it also would drop out. Does anyone remember how to tell it, how do we tell it that we're done entering input? Control D. So you need to get used to using Control D. Control D signals the end of input. So Control D signals, we actually call it, well, it's end of input. Technically, it sends what is called the end of file character, EOF, end of file character. So with command line tools, you hit Control D, and that signals end of file. At least on a Linux machine or a Unix machine. On Windows, Control D is supposed to work. You may have to hit Control Z on a Windows machine, though. But first try Control D. If that doesn't work, try Control Z. Okay, so first of all, we would sometimes like to know, did the program terminate because of an error or because of end of file? So we might come down here and want to print out whether the program is terminating normally or not. So if any of you remember, cin.eof indicates whether we've hit end of file. So if we hit end of file, I'm going to say normal termination. Else, I'm going to printf abnormal. Or I'm going to actually say printf erroneous input. So cin.eof will tell me whether I hit the end of the file. Okay, so over here, we run it, 6.0, 3.55, hit Control D, normal termination. Do it again, enter foo, erroneous input. So you can use cin.eof to tell you whether cin failed because it reached the end of file or whether it failed for some other reason. Now, for your lab, this will be important. In your lab, you want to keep reading numbers even if there is an error. Okay? So you don't want to stop even if you get erroneous input. Maybe you just want to get rid of the erroneous input. So you won't be able to anymore say while cin into number because the loop would exit immediately if that happens. So instead I'm going to say while true. And I'll tell you why in a moment, but just accept that for the moment. Now I'm going to say if cin into number I will print it. Else, I would like to check to see whether I reached end of file. So now I'll say else if cin.eof, because if I reached end of file, I would like to get out of here. Does anyone remember how you can break out of a loop? Break. So break will break me out. Else, if it's not the end of the file, it's erroneous input. This is where a comment is nice. So it's erroneous input. Now, what can I do to recover from erroneous input? So the analogy I want you to think of is a paper jam with a printer. When you try to read bad input, CN gets jammed, much like a printer jams. And when a printer jams, you typically do two things. First, you remove the paper that's jamming it, right? You pull it out. Secondly, you often have to hit a reset button. Okay? You have to do the same thing with CN. So when you have, move to the next page here. So when you have erroneous input, CN jams. Okay, to eliminate the jam, one, hit the reset button. The reset button for CN is the function clear. So call cn.clear, that's like hitting the reset button. 2, clear the jam. Okay, read the input, the erroneous, because the erroneous input is still there. It doesn't leave the input. So you have to clear that erroneous input. So read the erroneous input as a string, because a string will read anything. And you have to do it in this order. You can't clear the jam first and then hit the reset button. The reason is until you say clear, all reads will fail, even reads with a string. So it has to be this specific order. You have to call cn.clear first, then you have to read the erroneous string. Okay, so let's do that. So we first call cn.clear, so I'm going to say hit reset. Then cn into, and now I need to define a string variable up here, string bad input. Now I'm going to cn into bad input to get rid of the jam, or get rid of the erroneous. Okay? So now this will allow me to continue. You will need this code for your lab because you will need to be able to check to see whether something is a number or whether it is not a number. Okay, you won't actually be discarding bad input in the lab, but you will have two types or multiple types of input for your next lab assignment. Some of the inputs will be numbers, and some of the inputs will be non-numbers, and you'll need to check which is which. So a good way to do that is to assume that your input is a number, and if it is, you go ahead and do whatever processing you need to do with the number. Otherwise, the first thing you do is check to see if it's end of file, because if it's end of file, then you want to quit, you want to wrap up. Okay? Otherwise, in the lab, it won't necessarily be erroneous input, it will be some other non-numeric input that has meaning, like a command, and you will do something with it. But this framework of if, while true, if read into a number, if it works, do something with it, else check for end of file, else do something with the non-number. So you should probably have this written down because you will need it in the lab. I often get comments of, Dr. Vanderzanden didn't cover in the class how to do it. Yes, I did. Just not quite exactly like you'll do it in the lab, because you won't be in the lab discarding non-numeric input. Think in the lab what you're doing is, on one of them, you're computing students' grades. Well, you get a bunch of students' grades and then you get a student's name. The student's name isn't a number, but it's valid input. Once you get the student's name, you compute the student's average, and then you move on to the next student. And you don't know how many numbers you're going to get before you get the student's name. Okay, so let's actually run this, make sure it works. There's always the conceit that you think, hey, so it compiles. Let's start entering some numbers. Let's try entering foo. Hopefully that just discarded it. Yep. Discarded it. So it's working. It's discarding the erroneous input by not doing anything with it, and it's echoing out that it's proceeding on. Okay? Questions about this? Okay. This is important because in 102 we really didn't give you bad input often like this, but this is where we're delving deeper. We're giving you bad input sometimes, or we're giving you different kinds of input, and you have to be able to distinguish between the different kinds of input. So this is one way to do it. Assume that the input's a number. Then if it's not a number, check to see if it's EOF. If it's not EOF, clear the jam, read it as a string. Let me circle back. I said while true here. Why didn't I simplify things? And I'm going to quit out of here for a moment and go to eof.cpp. Going to quickly do the program again. Actually, let me just do number for the time being to show you the simple form of it. I could have presumably done this. Okay. Why not just simplify it? Instead of saying while true, why not just say while not cin.eof, read the number and print it out? Pardon? Well, it will break out of the loop eventually, because eventually EOF will be true. When it's true, this condition becomes false and I get out of here. Okay. It's very subtle, but we're doing this because it's a common error that many of you will make. So let's try compiling this. It's actually not obvious what's going wrong. Okay? I give it 10, it prints 10. I give it 20, it prints 20. Now I hit Control D. I'm hitting Control D. Whoops, that did not work. Okay, let's do something else. Input. Okay, here's an input file. Here's something that you need to get used to. Redirecting from standard input. So what we're doing here, this is a Unix command. The less than says take your input from this file rather than from the console. So the less than is saying take input from the file named input. So the less than character is called redirection. If you're wondering about it, Dr. Planck talks about it in his notes. So if you go to C++ review, reading from standard input, he talks about redirecting standard input from a file. And again, he goes over the less than. So it's in the notes. You can redirect standard input to a file. So that's what I'm doing here. Wow, it's working.
You're running.
I'm running the previous program? Oh, I'm running print. That's because I'm running print, not. Now let's run EOF. And,
CF Stadium.
pardon?
The CF Stadium.
Wait, what am I? Oh, thank you, using namespace std. Thank you. That's why it's so nice to have multiple eyes on it. Now let's do EOF. 10.5, number equals 10.5, 22.5. Now I hit Control D. What happened? It printed it again. It printed 22.5 a second time. That's an error. Let's do it from the file. That makes it clear. Here's the input. There's two numbers, right? Let's do the redirect. There's not three. There's only two numbers. This last number printed twice. Do we agree? Two numbers. The last number printed out twice. That's the problem with this code. The problem is that EOF is reactive, not proactive. So Dr. Planck likes to say that EOF is reactive, not proactive. What does that mean? Okay, because that's kind of vague. What it means is that EOF, what does this mean? Okay, what it means is that EOF only returns true after a read fails. After a read fails. So EOF can't magically detect the end of file. If your input is 320 and then there's actually, when you hit Control D, there is an EOF character. So what it looks like, your file looks like, although you can't see it, is something like this. After you've read 20, but before you read the EOF, there's a so-called cursor. Just like you have a cursor on the screen. Here's my cursor, right? There's also kind of analogy. There's a cursor telling C++ where it is in the input. You think that because the cursor is here, it can see that the next thing that it's going to read is EOF. It can't. That's what we mean. It is not proactive. It is backward looking. So another way to put it is EOF, based on this, EOF is backward looking, not forward looking. So probably it would be better to say EOF is backward looking, not forward looking. So EOF is looking at the last thing, which is 20. It's not looking ahead. when you use this code here, whoops, you assume that it's looking ahead. And it's not. So let's hand execute this to see what's going on. Okay, so here's our input file right here. Whoops. Our input, let me circle it. Here's our input file. So initially, the last thing it read was nothing. So initially, backward looking, EOF is false. So we come in here and read the number 10.5. And we print it out. Now we come up to the top here, and we're backward looking. EOF, the read succeeded, so it says we are not yet at EOF. So we come into the loop, and we read 20.486, and we print it out. Now we come back to the top, and it's backward looking. The last thing it read was success, so we're still not at EOF. It tries to perform this read again. Now it reads the EOF character. Okay, which means the read fails. What happens when the read fails? Whatever is there stays there. But we also advance and we try to print it. So we again print out 20.5. Now we come back up to the top. And finally, because it really did read the EOF character, we now exit the loop, but it's too late. That's why you can't put the test for EOF in the while loop or in the while condition. That's why I actually said while true. Okay, and I actually would have to put, if I was going to use EOF, I would have to put it right there. Because it's only after the read that we know whether EOF was reached or not. Okay, so this is really important because you don't want to be putting cin.eof in your while condition or you will come to grief. You'll read one, you'll appear that you read the last input twice. You really didn't. You just ended up failing. Okay, so just to wrap up for today, first of all, there is no challenge activities to do because there was no challenge activities for today's reading, so you don't have to do any challenge activities today. But do go and review Dr. Planck's 4 common CN errors. Okay, we've covered the 2 primary ones. Another one you want to be careful about is this one. You don't want to say if not CN into N1. The reason is this not binds tightly to CN. So it actually says if not CN, when what you want it to say is if the read has failed. So you always put your read in parentheses and then the not outside of it. If you don't parenthesize it and you put the not in front of the CN, then generally CN is true. Normally the last read was true, so it will return true and this will return false, and this will always fail. So make sure you put parentheses around your CNs if you're using not. Okay. We just talked about the fact that cin.eof is not proactive. It's backward looking. Okay. Cin reads words and not lines. I think by now you are pretty aware of that. I don't normally see this issue, but if you have a line of input, Cin will only it reads a word at a time. So if my input here, going back here, my input, I put it all on the same line, it will read each one's, whoops, it will read it one at a time. Okay, so EOF or CN reads one word at a time. It doesn't read the entire line. And remember to, well, I have to correct that typo. Remember to clear CN when it fails. First, hit the reset button with .clear, then clear the jam by reading the input into a string. Okay, so we have gone over the highlights of Dr. Planck's notes. You may want to quickly review them because it has a couple other less important things in it. Good luck with tomorrow's lab. If the roads are really crummy tomorrow, UT will almost certainly be open, but don't kill yourself coming into the lab. Try to, in that case, do it from home. So, and I will see you Thursday.
You don't take the compilation